This conference will now be recorded.
So
Good
very good
evening, sir.
evening, Deep. Yeah, good evening, Deepa. Today we are starting a new chapter, that is the last chapter of this. I think second last chapter, that is semiconductor devices and circuits, electronic circuits, etc. Okay, so semiconductor electronics, materials, devices, and simple circuits. So this is the chapter 14th chapter in ncert textbook. Today we'll have an introductory class, and next day onwards we'll learn very deep into the subject. So today basically we'll learn what are called electronic devices, what were available few decades ago, and now what is the advances in the electronic devices, and how do we classify materials, like how many types of materials are available in this universe. Then we'll see some basic classification of semiconductors, and finally I'll give you a little hint, a little idea about energy, electronic energy band diagram, and next day we'll discuss this band diagram or energy band diagram in detail. So let us start today's topic. So first we'll learn what is electronic device. So this, see, it is nowadays very easy to communicate in a second to the people anywhere in this world, right? We are having comfortable like life because of advancements in electronics. So discovery of electron actually was the landmark, because of which, so discovery of electron, after discovery of electron, the electronic technology speeded up, and there are lot of advancements in this electronic industries, and our life has become so simple and so luxurious. We can communicate, we can do many things with the electronic nowadays. Okay, and the basic thing is the electrons. Actually electronic, the term is coming from electron itself. So this is the guy which is actually doing the whole job in this electronic devices. So electrons, okay, and electrons, we know these are light particle having mass 9.1 into 10 to the power minus 31 kg. It has charge E, negative charge, okay, and it has value 1.6 into 10 to the power minus 19. These are the basic points we know. Coulomb, since it is a charged particle, it can be, actually its direction can be modulated by electric field or magnetic field, because of these properties of electron. somehow or other in the electronic devices, electron flow of electron is being controlled. Flow of electron is controlled in the electronic devices. So here it is said that any device, like any device, action of which is based on the control flow of electrons through it is called an electronic device. That means in any electronic device you have to have a control on the flow of electron. This is main thing, control on the flow of electron. Okay, so this is the main point over here. Any device where electrons are controlled, okay, so that kind of devices are called electronic devices. The flow of electron is controlled in those devices. So there are various processes to control the electrons or the direction or motion of the electron. Like you can use electric field, you can use magnetic field, etc. Now the branch of physics, which deals with this electronic behavior, electronic devices, and all those things is called electronics. Okay, electronics is a branch of physics which study which deals with the study of electronic devices, which deals with the study of electronic devices. Okay, that branch is called electronics, and these electronic devices are actually electronic devices are the basic building blocks of all the electronic circuit. So any electronic circuit you want to make, either you need resistor, then battery, there will be some conducting wires, electric circuit. So there are many things you need to make a circuit, right? So all those things are called devices. Now you might be thinking that electronic device is fine, but if we go to the history, then even some 100 years back, if you see, the electronic devices were vacuum tubes. Okay, electronic devices were vacuum tubes. What are vacuum tubes? I'll show you a figure or image of a vacuum tube. This is actually a typical vacuum tube. A vacuum tube. Actually, vacuum tube can have two electrodes. Those are called diodes. It can have three electrodes. Then they are called triodes, and there can be 5 electrodes. They are called pentode. Okay, there were various electronic devices with the vacuum tube systems. Okay, we'll discuss few properties of vacuum tube. Actually, what are vacuum tubes? Actually, vacuum tubes, as the name says, vacuum. There will be, as you see, this is actually the glass covering or glass envelope. This is a glass envelope. Inside that, what are there? There are two plates. One is called anode, another one is called cathode. And sometime in between there will be few more. Like if there is a grid, there is something called grid. There will be a grid, another electrode, that is called grid. So then it is called triode. If you have only cathode and anode plate inside the vacuum, then it is called diode. If you have along with anode and cathode, sometimes there will be a grid, then it is called triode, because there are 3 electrodes in that case. So what is there in this vacuum tube? You have 2 plates, metallic plates. One is called anode, another one is called cathode. This is for the diode. That means it has 2 electrodes. But if you are talking about triode, then there will be another electrode called grid in between. In between cathode, anode and cathode, there will be grid. Okay. All right. So you look how these devices work. In the vacuum tubes, electrons are actually generated from heated cathode. So you look, this is a cathode. Cathode generally made of tungsten or lab-6. Various type of materials are there which are used as cathode. So what happens? This cathode, okay, metal cathode, is heated to a very high temperature. Then what will happen? Electrons will come out, as you know, thermionic emission. Thermionic emission. Thermionic emission. Okay, so thermionic emission, that you know we have already discussed in photoelectric effect. So so you have to heat with very high temperature so that electrons comes out. So these are called thermionic electrons. And after electrons are coming out, see this cathode and anode, between them a very high voltage is maintained. You look, very high voltage is maintained between cathode and anode, and the polarity is given such that the electrons which are coming out from the cathode will be attracted to this anode plate. Okay, and that's how it will flow. It will give you the flow of current in this direction. Okay, and this can be actually controlled by, see this flow of current or flow of electrons can be controlled by this device. That's why it is called uh, yeah, so controlled by the difference in the potential, like potential difference between the cathode and anode plate sometime. Okay, is one thing. And here you might be thinking, why vacuum is needed? Why vacuum? Vacuum is needed because when the electrons are emitted by cathode and they move towards the anode, there should not be any gas molecules in between the cathode and anode, because then otherwise electrons will lose their kinetic energy, or their energy. They will lose their energy. by colliding with atoms and various gas particles. Okay, so then the flow, perfect control on the flow of electron cannot be attained. So that's why vacuum is needed. But there are few things we need to know. In case of vacuum tubes, flow always cathode to anode. So this is so only one direction. Electrons flow in vacuum tube. Electrons flow in single direction or one direction. Okay, that's why they are called as this kind of tubes are called valve. As we have valve in heart, they open in one direction only, or they allow blood in one direction. Okay, so similarly, this vacuum tubes were acting as valve because electron can flow at suitable condition in the from the cathode to anode only. Okay, but there are few disadvantages. The see size of this is looking in the image very small, but it has a huge size. So generally vacuum tubes are in size, they are very big, very big in size. So that's why they are not portable or not reliable. Another point is, see, you have to maintain vacuum as well as you have to heat the cathode. That's why you need to use or need to utilize very high power, very high power or very high voltage to operate both this cathode and maintain the potential difference between the plate. So because of this high voltage, there will be lot of loss. Okay, so nearly 100 volts are required to operate such kind of vacuum tube. Since these are bulky, consumes lot of power. That's why they are not reliable. And since every time this cathode is being heated and then cold, also to maintain the vacuum perfectly, it is very difficult. That's why as the lifetime is low, at the same time it is not reliable. So lifetime of vacuum tube is very low. So this is about vacuum tube. What we have learned: electrons are generated from cathode, then they are made to flow towards the anode and thereby through the circuit. Vacuum is necessary to avoid losing of energy of the individual electrons by colliding with each other or with the air molecules. Electrons can flow only one direction in the vacuum tube, so that's why they are called vacuum valve. and the vacuum tubes are bulky, consumes a lot of power. That's why they are not reliable or not portable. Now we'll learn about semiconductor electronic devices. So what are semiconductor electronic devices? So we have seen that in case of vacuum tube, you need to maintain a very high voltage and maintain a very high vacuum, as well as you need to apply high voltage to the cathode so that it can emit electrons. So these things are there. So they were not very reliable, and people were in search of alternatives. And in 1930s, 1930s, it was known that there is solid semiconductor. So there is solid semiconductor. So solid semiconductor and their junctions, solid semiconductor and their junctions offer the possibility of controlling the number and the direction of flow of electron. Okay, semiconductor device and their junctions offer possibility of controlling the electron through them. Okay, and to produce electron in this case, you don't have to heat a cathode or something. In this case, electrons are there already inside the solid semiconductors, but they are made to flow by applying suitable voltage or potential differences, okay, across the junction. And in case of solid semiconductors, no vacuum needed. So this is main point, that no vacuum needed. They can easily flow within the solid semiconductor. See, in case of vacuum tubes, you need to wait for the cathode to be heated, and then electrons generate, and then they pass from cathode to anode, so that they give rise to current. But for that you need some time. That means after switching on, you have to wait for the device to work. Wait for at least some time, because cathodes will emit the electrons. That is not instantaneous phenomena. It has to acquire proper heat to emit electrons. But in case of solid semiconductor, in this case electrons are already there. You need not produce them by heating them. That's why this phenomena is instantaneous. As soon as you apply voltage across the semiconductor, we'll see that electron flow occurs, and hence it start working, and it does not require very high voltage to operate. Okay, in case of semiconductor, to make a charge carrier or to increase the charge carrier, you need to simply make a light to incident, or you just need a very small heating to produce electronic charge carriers or charge carriers, simply charge carriers. Now, in semiconductor, there are two type of charge carriers, P and N. P means hole and N means electron. So there are two types of charge carriers. So Again, double advantage you get here in the solid semiconductor devices. And solid semiconductor devices are actually very small in size, first of all, and you need very less power to operate it, and their lifetime is also very high because there is no vacuum, no heat, no much heat, or the external condition changes in the semiconductor devices when it works. So that's why it has a greater lifetime. Okay. So what are the points we have learned for solid state semiconductor? For solid state semiconductor, we have learned that you need not have vacuum. So this is solid state semiconductor. No vacuum needed. Okay, let me write just small point. No vacuum needed. Then less power. To operate. Okay. Then small in size. Okay. Hence it is reliable to use. And fourth point we have discussed that lifetime is long life. Okay, so these are the points we have discussed over vacuum tube. Now what we'll do, we'll classify materials depending on the relative values of resistivity. So let us write that depending on resistivity and conductivity, materials can be divided into three categories. Three categories. What are those? One is metal, then insulator, and semiconductor. Okay, so see, for metal, it has very less resistivity of the order of nearly 10 to the power minus 2 to 10 to the power minus 8 ohm meter, and it has sigma just opposite. Sigma means 1 by rho. Okay, so this is Siemens per meter. So these are the values actually you should sometime remember. And then insulator, in case of insulator, rho is very large. In generally, rho has to be 10 to the power 10 to 10 to the power 19 ohm meter, and just opposite will be sigma. Sigma will be 10 to the power 10 to the power 19, and these are actually Siemens per meter. And semiconductors, they have actually resistivity and conductivity in between insulator and metal and insulator. So semiconductors have 10 to the power 5, this is ohm, 10 to the power okay. So this is actually, sorry, this is rho, resistivity, and sigma. Sigma is actually for semiconductor 10 to the power minus 2 0. That means it is 10 to the minus 1 to 0. It has sigma semiconductor Siemens per meter. Okay, so by the relative value of this, okay, so for semiconductor actually it is resistivity will be 10 to the power 5 to 0. This is 0, almost 0, and sigma will be 10 to the power minus 5 to 10 to the power 0. Okay, these are the typical classifications based on the relative value of rho and sigma. So we have already learnt about metal, because metal has free electrons, so they can conduct electricity very well. And insulators, since they don't have free electrons, they cannot in general flow electron, in general they cannot conduct electronic current or electric current so easily. But semiconductors, they have few special properties. We will discuss what are special properties of semiconductors. So before we go to the other topic, we'll learn few introductory properties of semiconductor. Semiconductor, they have much higher resistivity than metal. Okay, that we have seen. Now semiconductor devices have actually temperature coefficient of resistivity. Temperature coefficient of resistivity. And this temperature coefficient of resistivity is very high and negative. So semiconductors have negative temperature coefficient of resistor. Negative temperature coefficient of resistivity. Okay, that means what? If you plot resistivity with respect to temperature, suppose this is absolute temperature, resistivity decreases like this. It goes like this. So this is rho, this is temperature. But in case of metal, it generally grows like this. Okay, proportionally grows for metal. This is for metal. and this has positive temperature coefficient, but these are rough drawing. Actually, metal should not start from 0. Generally it starts from some value. Okay, resistivity never becomes 0 in normal case of conductor. There are superconductors at certain temperature their resistance will be 0. So generally it starts from here for metal. And there are many other complexities of resistivity plot with temperature. That complexities we are not going. And for insulator also the same thing. Insulator also resistivity decreases little bit, but uh, for semiconductor it has negative temperature coefficient of resistivity. Okay, so that is the main point over here. And semiconductors, number density of semiconductor number density of the charges of semiconductor are actually less than metal. So these are few properties of semiconductor. Now if we classify semiconductor on the basis of their composition, there are two types of semiconductors. One is elemental. So according to composition, one is elemental semiconductor like silicon, germanium, then gallium arsenide, etc. Mainly these two, you remember this. And there are many other elements which can weakly act as semiconductor. Then if we go for compound semiconductor, compound there can be organic, polymer, or inorganic. So if we consider inorganic, then gallium arsenide are the example. So inorganic semiconductor. Okay, we'll write it here. So compound semiconductors have three divisions. One is inorganic, organic, then you have organic semiconductor, and you have polymer. Okay, polymer semiconductor. So you have to remember example, at least 2-3 examples for each. Like this is CDS, we can write cadmium sulfide. CDSE, cadmium selenide. Gallium arsenide, GaAs. Gap, it is at gap. Gallium phosphide. Okay, gallium indium phosphide. So those are inorganic compounds. Organic, you can remember some names of organic polymers. Okay, generally organic polymers. Organic and polymers, actually these are called organic polymer only together. Okay, so you can have polythiophene, thiophene, then polypyrrole, etc. So these are compound semiconductor. in organic polymers. Okay, so these are brief introduction about semiconductors and various like various classifications of various materials based on their resistivity, etc. And we have learned what are called vacuum tubes, what are semiconductor solid state semiconductor devices, and what are the advantages and disadvantages we have seen. Now I'll just give you a brief idea about band structure, since semiconductor is the main focus in this chapter. We'll be learning in details about semiconductor, and semiconductors will be defined according to band structure, also electronic band structure. We have learned in the hydrogen atom chapter, like in the atoms chapter, there we have learned simple hydrogen has nucleus and only one electron outside. This is an isolated hydrogen atom. But if you see water molecule or many other molecules there, or you just take a simple solid of any material, like you can take a silicon atom, simply a silicon atom. But when you take a silicon wafer like this, they have lot of atoms, like more than Avogadro number. Okay, at least Avogadro number of atoms are there. So when there are atoms coming closer and closer to form a solid, see that electrons are actually in the outer orbit. The electrons, they start interacting to each other. They start interacting to each other. What is that kind of interaction? That is electrostatic interaction. So that starts in interacting with each other, and energy level gets splitted up because of this interaction energy. Suppose you have, in case of simple hydrogen atom, single atom, you have ground state energy, then you have first excited state, then second excited states, etc. You have various energy levels. Okay, these are just a line simply a line. That means energy has a single value. If uh, this is 13.6, that means it is 13.6. Okay, so if this is 3.4 electron volt, that means this line is a single valued energy line, single valued line. Okay, now when you bring many atoms together very close to each other, then because of this electron interaction, these energy lines of the energy level, they will be actually splitted into a number of energy levels, the single levels itself. Okay, so a single energy level gets splitted up into various small energy levels, like there are many energy levels. So when they get splitted up, there will be energy levels, various energy levels together. Okay, these are called degenerate states. Okay, and this splitting of energy levels will be again increasing if the interatomic distance becomes lesser and lesser, and at some time you will see there will be no gap between the two energy levels. You look here, so this energy, a single line actually gets splitted up, various energy levels are just adding up, and they create various equispace various levels of energy, and then together they form a band. Okay, together with many energy levels, together they form a band. So these are called energy band, and there is a gap between them. This is called energy band gap. So depending on this band structure, we can classify materials which are conductor, semiconductor, and insulator, etc. So these things we will learn in detail in the next class, because there are very many great detail points over here which I'll discuss in the next class. I'll stop it here for today. Deepa, if you have any question, you can ask me now. Do you have any question, Deepa? I'm not getting any response from you. Okay, I'll stop it here. Bye for today.